Hello everyone, welcome back to the channel. Now in this video we are starting with sorting algorithms. Okay, we are going to learn a lot about sorting. Okay, we are going to learn about bubble sort, selection sort, insertion sort, merge sort, quick sort, counting sort, bucket sort, all those techniques. Okay, so for now we are starting with bubble sort. This is not algorithm that you want to use in real time, but this is the algorithm from where we start learning the sorting, right? Let's understand how we implement bubble sort, okay, and what is the time complexity of it. We have created a method, private. This you can make public void bubble sort numbers. Okay, let's create first loop, I is equal to 0 to I is less than numbers dot length I plus plus. Take another loop for j is equal to 0, z is less than numbers dot length and j plus plus. Okay, now what we are supposed to do, we are supposed to check if numbers of j is less than numbers of j minus 1. Now since we are writing this j minus 1, right, we are supposed to start with first index. Okay, now what we are supposed to do, if the number at j index, that means first index, is less than the number which is just before the index, 0th index, we are supposed to swap it. That means replacing, changing their location. Numbers j and j minus 1. Let's implement our swap method. See, all this method will do, it is going to take these two indexes, okay, index 1 and index 2, and it's going to replace their values. That's it. So let's do that. Int temp is equal to numbers of index 1, and numbers of index 1 will hold the value of numbers of index 2, and numbers of index 2 will hold the value of temp. You can do the same thing without using third variable as well. This is also one of the interview questions, swap two variables using third variable or without using third variable. So this is with using third variable. Okay, so now that we are done with this, ideally we are done with the implementation. If I'm trying to run this, right, I will get this array sorted. So you see there is a lot of numbers are there which are not in a sorting order. Let's try running the application program, and as you can see the array is sorted, right? So ideally we are done with the implementation, and if you have gone through my time and space complexity video, you will know this is an O of n square time complexity. That means quantity time complexity, which is not really a good time complexity, to be honest. Okay, we want to somehow do the operation in less than quantity time complexity, unless it's really necessary. Okay, so what are the optimizations that we can do here? Let's think about that. Let's say the list, the array that you're passing, right, is already sorted. Okay, so take a boolean variable for that. Boolean is sorted. Okay, and I'm assuming after every single iteration, okay, the array is already sorted. I'm keeping it true. Okay, so if this condition fails, right, and we have to swap the value, that is when we know that your array is not actually sorted. Okay, so that is when we change this flag value, we change it to false. And let's say you have done zero swapping, that means your array is already in a sorting order. That is when this is sorted flag value will still remain true. So when you're coming out of this loop, right, you will check if this is sorted value, right, if it's true, just return there itself. You no need to do other passes. Like, that is the first optimization that we have done in bubble sort. Now we can optimize it one more way. So in bubble sort, what happens after every single iteration, right? The last index value, let me run this. Okay, so we are getting this sorted array. So this last value, right? After every single iteration, we are making sure this last value is already in a correct position in a sorted array. Okay, so every single time comparing with this last position, right? And in first pass this last position, in second pass this position, in third pass this position, and so on, is not really necessary. Okay, so to avoid that, what you can do, you are iterating through this just j is less than numbers dot length, right? We'll be iterating j is less than numbers dot length minus I. That's how you can actually skip those checks in every single pass. Okay, so let's run the application. Let's run the program. I'm telling application every single time, although it's a sorting application kind of. As you can see, we are getting the right answer. Our array is sorted and we have done two optimization. Okay, one is checking if the array is already sorted, and second is, if we already know that every single iteration, after every single pass, the last index or second last index, in the subsequent passes is already in a correct position, then we are trying to avoid checking those position. Okay, through this particular expression numbers dot length minus I. So I guess that's it. This is the bubble sort algorithm. Okay, that's all as part of this video. See you in the next one. May the source be with you.